Hello, everyone. Welcome to part one of Don't Make Me Think, Why Smart People Make Dumb Choices. In this part, we'll look at perception problems and logical errors. On January 25, 1995, word went out on police radios that 4 suspects were fleeing the scene of a cop killing. At one point, several officers gave chase to one suspect on foot. The officer closest to the suspect was a plainclothes undercover cop wearing pants and a jacket similar to the suspect's clothes. The suspect scaled a fence and the undercover officer went after him, but got hung up on the fence, and as he jumped down, the suspect continued on. Just as the undercover cop was about to scale the fence again, a group of uniformed cops arrived, mistook the officer in plain clothes for the suspect, pulled him down off the fence, and began beating him brutally. Meanwhile, a single officer in pursuit of the suspect arrived on the scene, scaled the fence next to the beating that was taking place, continued pursuing the suspect, and eventually caught him. At subsequent hearings, the officer who eventually caught the murder suspect denied having seen the beating taking place as he rushed past in pursuit of the suspect. Many people believed that he was covering up what he must have seen in order to protect fellow police officers. At a later trial for perjury and obstruction of justice, the officer testified that he didn't see the plainclothes officer chasing the suspect, did not see him trying to grab the suspect on the fence, and didn't see the other officers beating him. But he agreed that he should have seen it. The jury convicted him of perjury and obstruction of justice, and the judge sentenced him to 34 months in prison. Quite possibly, you agree with the jury. How could the other officer, Kenneth Conley, not have seen something so dramatic as a brutal beating right there in plain view? I mean, come on. We would have seen it, right? We all would. Well, we'll see about that. Since 1989, more than 250 people in 34 states have been exonerated through post-conviction DNA testing. Many of these people were originally convicted largely or almost exclusively on the strength of eyewitness testimony that later turned out to have been mistaken. Unless they've had a course or two in psychology, most people have a naive view of the mind. When we look, we see what's there. When we listen, we hear the sounds around us. When we enter the kitchen, we smell the onions frying in the pan. And when we sit down, we touch a real chair. We perceive what's there, and it's really there. We're not imagining things. In essence, we think of the perceptive parts of our minds as similar to cameras, video recorders, and surveillance equipment. Our minds record and recall what's there. If we have this naive view of minds, we too would probably convict Kenneth Conley, the officer who denied seeing what he himself said he should and would have seen, but claimed he did not. The naive view of the mind also believes that our beliefs are sound, our judgments are usually good, and we're generally in control of what we think. Sure, we know we occasionally make mistakes, but these mistakes are momentary lapses or occasional glitches. They're not the result of a mind not suited to the task of perceiving and making judgments about the world. The results of the last 130 years of research in psychology lead to one overriding conclusion. Our minds are not what we think they are. They are not photography machines, tape recorders, or blank slates on which interactions with the world are written. They are not computers that process information gathered from experience. They're not even all that good at making judgments. Judgments about lawsuits, investments, whether people are lying, what time we'll get home this evening, or whether the government should expand or cut spending during a recession. Let's begin by examining whether we really perceive what's there. What do you see? 2 tables, right? Are they different sizes? Oh, yes, of course they are. Any fool can see that. Table number 1 is long and narrow. Table number 2 is short and wide. If I weren't showing them to you in this presentation, you might even be willing to bet money that they're not the same size. Certainly they couldn't possibly be congruent. Our eyes and minds clearly see 2 different tables that are 2 different sizes. But let's see if we can line them up side by side. I'll turn number 2, the short one, on its side and move it close to number 1, the long one, like this. Now, cutting and pasting like this is not exact, but you can see that the short one is as long as the long one. Want to see it again? Why don't we put the short one alongside the long edge of the long one and also against the end? It's obvious that the short one is much wider than the narrow one, isn't it? So now number 2 is aligned with the length of number 1 and with the width of number 1. It's the same table. But you still don't believe it, do you? Well, as Richard Pryor might say, who are you going to believe, me or your lying eyes? Okay, maybe I'm using the long table twice or doing some other trick. Well, let's watch this little video. Still not convinced? Well, go to our website and print out the copy of the 2 tables I uploaded into this section and measure them with a ruler. Go ahead. Pause the video. We'll still be here when you finish that exercise. Okay, so now you probably believe the 2 tables are congruent. But, you may say, this is an optical illusion, a trick created for effect. But does it prove anything about how our minds work when dealing with reality? These 2 monsters are exactly the same. Don't believe me? This video will prove it to you. We could spend a week, a month, or a year discussing different manifestations of perception errors. Optical illusions alone provide abundant grist for the mill. Here, M.C. Escher's waterfall goes down and back up at the same time, all in an endless, impossible loop. This duck is a fascinating creature. This rabbit looks very similar. In fact, you might even say the rabbit is identical to the duck. If you look at this cube for even a few moments, you'll see the front shift from one panel to another. Putting another cube beside it that does not have the back lines drawn makes the effect even more dramatic. The Harvard program on negotiation uses the Necker's cube, as it's known, as part of its logo. I'm going to show you a short movie. Your job is to count the number of times that the players in white pass the ball to each other, either in the air or as a bounce pass. Ready? Just count the passes. How many did you get? Write the number down. How sure are you that your number is correct? Could you have missed 1 or 2? The correct answer is 16. If you got from 13 to 16, you're in the company of most people. If you counted fewer than 13 passes, you may disagree. But perhaps you missed 1 or 2 passes. Would you agree that you could have missed a few? After all, the ball is going different directions. So don't feel bad if you didn't get 16. In a moment, I'll play it again so you can check it out for yourself if you like. Oh, by the way, did you see the gorilla? What gorilla? What are you talking about? Well, a gorilla walks into the scene as the women are passing the basketball, stops, looks forward, pounds its chest, and then walks off. Want to see it again? So now you saw it. About 50% of the people who see this video for the first time and who've never heard of it see the gorilla walk on stage. But the other 50% don't see it at all. In fact, a good number of those who don't see it the first time think that the presenter plays a different video the second time. They're sure that the gorilla wasn't there the first time. And if you're thinking that, rewind this video back to the first presentation and play it again. If you've seen this video before or heard about it, you probably saw the gorilla without any problem. But did you see the student in black walk off when the gorilla came on? And did you notice that the curtain changed color? The student walking off is in the upper right-hand corner, and the curtain is gold, and there are only 2 players in black left at the end of the clip. Daniel Simons created this video for use in psychology experiments. In the original, there was no curtain and no color change, and no one walked off the stage except for the gorilla. The clip is now famous. This version has been viewed on YouTube more than 3,300,000 times. Just Google "the monkey business illusion" to see it for yourself. The video illustrates a mental phenomenon called inattention blindness. Basically, we often don't see things we're not looking for, or we don't see them if we're paying attention to something else. Our minds have only so much attention capacity, and when they're focused on one thing, they easily miss other things. So does this invisible gorilla remind you of anything you've seen or heard about recently? What about the Kenneth Conley story I related at the outset of this video? Kenneth Conley didn't see the gorilla either. That is, he did not see the beating going on next to the fence when he went over it in pursuit of the bad guy. No one believed him. How could he not see the gorilla? Actually, the relationship between the invisible gorilla and the Kenneth Conley case is even closer. A journalist who followed the Conley case heard about Simons's research and brought Conley to Simons's lab. Simons investigated the case, and the experiments he and Christopher Chambers have conducted were instrumental in the ultimate exoneration of Kenneth Conley. The book not only tells the story about the Conley case and the invisible gorilla research, but it also relates the results of other studies on inattention blindness, as well as insights into how our minds work that are of particular interest to lawyers. For example, the experiments on the illusion of knowledge demonstrate that we think we understand how and why something functions the way it does until we have to explain it, and then we're quickly stumped. So far, we've discussed 2 kinds of perception problems that trip up our decision-making. The first is seeing what isn't there, or seeing things differently than they are. This was illustrated by the Shepherd tables, which appear to be dramatically different in width and length, but are in fact congruent. The 2 monsters that looked different in size but were identical, the rabbit and the duck, and the Necker's cube illustrate the way shifting perspectives can lead us to see the same thing as something different. We could have looked at hundreds of examples of these kinds of perspective-based perception problems. Our perception problems extend to failing to see what is there. This is memorably illustrated with the invisible gorilla video. But we all know instances of not seeing something because we're deep in thought or distracted by something else, such as a cell phone call. More than half of all motorcycle accidents are collisions with another vehicle, and in over 65% of these, the other driver didn't see the motorcycle. This picture shows the aftermath of a collision in which the driver of the VW pulled out of a side street without seeing the oncoming motorcycle, which was going 85 miles an hour. The driver of the motorcycle and the motorcycle itself ended up inside the VW. All 3 people were killed instantly. Anyone who's ever tried a lawsuit or even participated in a contested hearing knows that it's impossible to keep everything in mind. If you watch the jury, you don't fully hear what the witness said. If you're focused on your upcoming cross-examination, You may miss an unexpected statement the witness makes on direct. If you're ready to pounce on every question that elicits inadmissible evidence, you may not see the witness's demeanor or how the jury is responding to the witness. Inattention blindness is a fact of everyday life. Do perspective problems and inattention blindness exhaust the menu of perception problems that bedevil our minds and cause serious judgment problems in the case valuation context? Not by a long shot. Let's talk a bit about the problem of misremembering what we think we experienced. Not only do we see things that are not there and fail to see things in plain sight, but we remember things that never happened or that didn't happen the way we remember them.
I remember landing under sniper fire. There was supposed to be some kind of a greeting ceremony at the airport, but instead we just ran with our heads down to get into the vehicles to get to our base.
But Hillary Clinton misremembered. She had a false memory. Here she is in Tuzla walking across the tarmac, and here she is with some troops on the same day. Why did Hillary Clinton say she had to avoid sniper fire? Elizabeth Loftus and other memory experts have suggested that when she was preparing for the trip and in the process of landing, various security people had stressed the potential dangers involved, and Bosnia was notorious for having been terrorized by months of sniper fire. This anticipation and anxiety got mixed up with the real experience. Her mind confabulated facts and fears into an inaccurate memory. Here's how Professor Loftus explained the matter in a Chautauqua talk.
fMRI, and in this work you can look at people who are reporting true memories or reporting false memories, and well, occasionally you can see statistical differences in brain activity in the true memories versus the false memories. The overwhelming picture here is that the brain signals that are occurring during the recollection of a true experience and a false one are very similar to each other. We are a long, long way away from being able to use neuroimaging or some of these other brain recordings as a way to help us tell whether an individual memory is a true one or a false one. So I just want to say that our work does have theoretical implications. A lot of what we do in academia, of course, is to try to develop theories for what is happening, in this case, theories for how the mind works and how false memories develop. We're close to having a recipe for how you get people to have a false memory. First, you make the event seem plausible. Then you work on a person to make them believe it happened to them. Then you engage them in imagination and other processes to add sensory detail to the bones of the belief, and you're on your way to a really rich false memory. But there are also practical implications. We can change cultural memory as well, and I'm going to skip over these studies where we got people to remember public events differently, just in the interest of time. The practical implications involving nutritional selection are pretty obvious. If we can plant false memories about your experiences with food and help you affect your nutritional choices, maybe make a dent in the obesity problem in our society, we might be able to put these false memories to some use. And of course, there are many implications for potential legal reforms, the way our legal system interacts with people who will become witnesses and victims testifying in court, so we do reduce those number of wrongful convictions and have a fairer system. And I'll end then, as I began, with Hillary. She landed under sniper fire. That's not the way it really happened. We've got two explanations for what might be going on. There's the Pinocchio one, insinuating she's lying. But if I were an expert witness for Hillary, I could certainly support her explanation. I made a mistake. I had a different memory. It can happen to the most experienced, talented, and intelligent.
I first saw the word confabulation while researching the effects of hypnosis on the memory of a witness in the Andrew Wilson murder case. I assisted Barry Sullivan in writing Wilson's appellate briefs in which we discussed numerous errors committed at the trial level, including the court's failure to exclude a confession obtained through brutal police torture, all resulting in a conviction and death sentence. The police had arranged to have an eyewitness hypnotized, hoping that he would be able to remember the license plate of the killer's automobile. Over defense counsel's objection, the witness testified at trial that Andrew Wilson and his brother Jackie were the assailants. People under hypnosis are in a highly suggestive state and tend later to confabulate real events with suggested or imagined ones so that they become one resolute memory. In their minds, the real is indistinguishable from the unreal, much like Hillary Clinton remembered what didn't happen. We argued that this testimony was irretrievably corrupted by suggestions made during the hypnosis. The Illinois Supreme Court reversed the conviction. Wilson was convicted again, but this time sentenced to life in prison, where he died of natural causes years later. But confabulation of this sort is not limited to hypnotic suggestion. Memory experts have shown that confabulation happens more often than we realize in everyday affairs, particularly in connection with emotionally charged experiences such as car accidents, robberies, rapes, and other violent acts. We could spend an entire course exploring how memory works and why we get false memories. The main point is that our memories do not retrieve experience from a mental filing cabinet. They construct what we think happened from bits and pieces of data that make sense. In perception, as in other parts of the mind, context is king. We see what we expect to see. We don't see what we're not expecting. We miss things when our attention is focused on something else. We think things are one thing when they're another, and we misremember what we thought we experienced. And much of this faulty perception comes about because of the context in which we see, hear, touch, and think about things. Most of the time, these mistakes are not consequential, but occasionally they can even put people behind bars or on the scaffold. Let's move to another category of mistakes our imperfect minds tend to make: logical fallacies. Every card that has a D on one side has a 3 on the other. Which cards must you turn over to test the truth of this statement? If you said the D and 7 cards, then you got the answer right. If you said the 3 or K cards, then you got it wrong. Why? Because the statement will be false only if a card has a D on one side and any number other than a 3 on the other. The statement will be true even if a card has a 3 on one side but no D on the other, and it will also be true if the K has a 3 on the other side. K is irrelevant, as is the reverse side of 3. About 90% of the people who perform this selection task in this form for the first time get it wrong. Most often, they turn over the 3 card as well as the D and 7 cards. But only the reverse sides of the D and 7 cards need to be examined. Why do they get it wrong? It seems like a simple task. It doesn't require knowledge of mathematics or even formal logic. Any human mind of average intelligence can understand the solution immediately. And the vast majority of us get it wrong. In other words, smart people make dumb choices. Why is that? To begin with, it's not a simple problem. It's a complex problem. To solve it, your mind first has to discern the logical relationship being asserted. In effect, it must translate the question into the form of a conditional relationship. Framed the way Peter Wason put it, the statement is not as clear as it could be. The translated version says, if a card has a D on one side, then it has a 3 on the other. When we make this one change to the task, fewer people get it wrong. Here's another way to present Peter Wason's card selection task. Which cards or cards must you turn over in order to find out whether every card with an even number has a red back? Answer: the 8 and brown cards. Whether the 3 has a red back doesn't matter. 3 is not an even number. Similarly, any number or no number could be on the back of the red card without disproving the statement. But if there's an even number on the back side of the brown card, then you know that not every card with an even number has a red back. Here again, notice that the form of the question influences the ease with which the mind solves the problem. Our minds still have to translate the question subconsciously, but the form here is less confusing, and fewer people get this version wrong than get it wrong in Wason's original presentation. The Wason test presents a complex reasoning test and tricks the mind into committing a logical fallacy. We sometimes find ourselves saying something like, "It has a red color, therefore the number must be even," and we conclude that we must turn it over to check whether this is true. If not, our minds reason, then the statement must be false. But that reasoning is fallacious. Logicians call this kind of mistake the fallacy of asserting the consequent. Logically, a true statement can follow from anything. However, that doesn't make the first part of the statement, the part following the if, necessarily true. Here's a true statement. If the moon is made of green cheese, then the sun is hot. Here's an example of the fallacy of asserting the consequent. The sun is hot, therefore the moon is made of green cheese. It's easy to see the mistake here because we know that the moon is not made of green cheese and we know the sun is hot. But the more abstract version is less obvious. If a D is on one side, then a 3 must be on the other. A 3 is showing, therefore a D must be on the other side. That's a fallacy, and it's not so easy to see why that's a faulty inference. Or take another example. If it rains, the picnic will be called off. This says only that it cannot be true that it rains and the picnic goes ahead anyway. But it says nothing about other reasons the picnic might be canceled. A death in the family, for example. And it says nothing about what will happen if it doesn't rain. It doesn't say that the picnic will take place if it does rain. That's an entirely different statement. It says merely, if it rains, no picnic. When we lay the reasoning error out in words like this, it's easy to see and name the problem, to identify it when it happens, and to correct the mistake. The Wason card selection task, on the other hand, presents us with a level of thought complexity that takes advantage of our tendency to falsely reverse the logical relationship, and in so doing, can easily confuse us. You would be wrong to think that this problem tests general intelligence or that smarter people get it right and less smart people are the ones who get it wrong. Consider this version. Robin Hogarth and Hillel Einhorn of the University of Chicago told a group of professors and graduate students in the statistics department of the University of London that an expert stock market analyst claimed that the market always went up after he predicted that it would rise. Which of the following things would they need to check to verify the analyst's assertion? What the market did after he predicted that it would rise, what the market did after he predicted that it would fall, what he predicted before the market rose, and what he predicted before the market fell. 48% of the professors and graduate students in statistics at the University of London said that you need to check only the first statement. But you need to check both the first and fourth statements. If he predicted that the market would rise and it actually fell, his claim would be wrong. So you have to check that statement too, the fourth one. The other two statements are irrelevant. But Hogarth and Einhorn misdirected the statisticians, just like Wason misdirected the subjects in his original study, by asking them which events they needed to check to verify the truth of the analyst's claim. They did not ask them what they would need to do to falsify it. But this framing change can make a big difference. Presumably, these professors and graduate students were very smart, and they work in a field that puts a premium on logic. Yet only 22% of them got the right answer. And remember, we're exploring why smart people make dumb choices. What goes on when our mind isn't looking is one of the answers to that question. Let's look at the effect of context and framing. Here the cards represent what the 4 Goldstein children did. The mother of the 4 Goldstein children has a rule. If you borrow my car, then you have to fill up the tank with gas. Which cards must we turn over to find out whether one of the Goldstein children broke the rule? This would be easy, even if we hadn't been discussing the logical relationships involved. You don't have to fill up the tank if you didn't borrow the car. So we don't have to turn over the did not borrow car card. And if you filled up the tank, then you could have done that whether or not you borrowed the car, so that we don't have to check the filled up tank with gas card. So only the first and last cards must be checked. 76% of undergraduates tested on this form of the problem got it right. This is called the social context version of the problem. We tend to get the correct answer when the problem appears in a social relationship form of this nature or involves a behavioral rule. But notice as well the way I framed the question. I asked, which cards must we turn over to find out whether one of the Goldstein children broke the rule? That way of putting it, that framing of the question, is subtly different from the way the original Wason test put it. Which card or cards must you turn over to prove that the statement is true? One form asks to check whether the statement or rule is false. The other asks whether it is true. That subtle distinction can make a difference in what people do. Okay, you might be thinking, that's all very interesting, but what does that have to do with estimating the values of the 4 components of case valuation, or litigation in general, for that matter? After all, we're never asked to figure out which cards we would have to turn over or anything like this Wason selection task. It's not something we'll ever do in court or mediation or any part of litigation. My response is that we and other players in the litigation process frequently encounter logical relationships like those presented in the Wason selection task. But such reasoning tasks seldom arise in the form of an abstract logical question. Rather, they occur as people try to make sense of the evidence and assess probabilities. For example, suppose the Svensson case has gone to the jury and the jurors are thinking about whether George harassed Kristen. Someone says, well, of course George must have harassed her. She didn't get a raise. Therefore, he must have been coercing her to have sex with him before and was retaliating for her refusal to continue. Restated in its logical form, the juror is saying, if George harassed Kristen, then Kristen didn't get a raise. Kristen didn't get a raise, therefore George harassed Kristen. The juror has committed the logical fallacy of affirming the consequent. Kristen could have failed to get the promotion for any number of reasons, including poor performance. Part of our job as litigators is to anticipate reasoning challenges of this nature and to frame arguments and the presentation of evidence to minimize them. We need to be looking out for framing traps as well when we estimate liability, probability, contingency probabilities, and damages. Why do so many people get the Wason selection task wrong on the first try? Wason reasoned that we tend toward verification rather than falsification. He put his explanation this way. The combined results of 4 experiments show that the subjects are dominated by verification rather than falsification. They fail to select the 7 which could prove the statement false, and many select 3 which could not falsify the rule. In other words, we look for evidence that will prove the statement true, not evidence that will show that it is false. The larger topic involved is our tendency to seek out evidence that will verify a statement, which is a particular version of the confirmation bias that plays such a big role in getting good estimates. Peter Wason, by the way, coined the term confirmation bias. But Wason predisposed us to look for verification, not falsification, by the way he framed the question. Which cards must you turn over to test the truth of this statement? We probably read that as another way to say, verify the statement. Wason did not say, which cards must you turn over to show whether this statement is false, or what must you do to show the statement is false. But you would have to do the same thing in response to the different form of the statement. Fewer people would get it wrong. A similar framing effect occurs in courts when the judge instructs the jury about the burden of proof. Basically, she's telling the jury that the plaintiff must verify its claim, and this tells the jury that it must find evidence to verify that claim. When the standard is a preponderance of the evidence, the jury can find for the plaintiff if it finds a scintilla more than 50% of the weight of the evidence in favor of the plaintiff. If the jury is predisposed toward the plaintiff, it's an easy matter to confirm that predisposition by selecting some evidence and disregarding other evidence. The implicit burden of the defense is to falsify the claim, to disprove it by more than 50% of the evidence. This may be a more difficult burden psychologically, even though it appears to be basically the same as the plaintiff's burden. In a criminal case, however, the defense need demonstrate only that there is a reason to doubt the defendant's guilt. Here the judge is explicitly framing the burden in terms of falsification, which is psychologically an easier task. The evidence of guilt can be overwhelming, but if there's any basis for reasonable doubt, the jury may not convict. Defense attorneys who understand the psychology of this setting have an easier time. Let's turn to something else. Suppose I put 10 jelly beans in one jar and 100 in another. In the first jar, there's 1 red bean. In the second, there are 9 red beans. I put the jars behind a curtain so you can't see them, and offer to let you choose a jar from which you can take out 1 bean. I give you $10. You'll have 7 chances to draw a red bean from a jar. Each time you draw, the setup will be the same. That is, one jar will have 10 jelly beans, 1 of which is red, and the other jar will have 100 jelly beans, 9 of which are red. For each red jelly bean you draw out of a jar, you'll win $1 for a maximum of $7 plus the $10 I gave you to start with. Which jar would you pick to draw from? Given that choice, most people pick the 100 bean jar. In studies conducted in the early 90s, 82%, that is, 82 out of 100 participants, chose the 100 bean jar at least once when given a chance to receive $1 for each red bean. Clearly, if money or even red beans is your objective, that's an irrational or suboptimal choice. There's a 10% chance of getting a red bean out of the 10 bean jar and only a 9% chance with the 100 bean jar. Yet most of us tend to choose the 100 bean jar. Now, suppose after you've had an opportunity to win up to $7 by picking a red bean, we play 5 rounds of the same game. This time, I'll take away $1 for each red bean you draw. Which jar would you choose from for this part of the game? The 10 bean jar or the 100 bean jar? In this condition, you have a better chance of keeping your dollar by picking the 100 bean jar because the ratio of red beans to black beans is lower. Only 9% of the beans in the 100 bean jar are red, while 10% of the beans in the 10 bean jar are red. The 100 bean jar is the rational choice in this condition. Yet 61% of the participants in the study chose the 10 bean jar at least once out of the 5 rounds in which they would lose $1 for each red bean chosen. The scientists conducting this experiment varied the number of red beans in the 100 bean jar, reducing the number in one trial to as few as 5. Many participants continued to choose the 100 bean jar over the 10 bean jar when they would receive $1 for each red bean. When the 100 bean jar had only 5 beans in it, 23% of the participants still chose the 100 bean jar. Statistically, the chance of getting a red bean from the 100 bean jar under those conditions is exactly 1/2 of the chance of getting a red bean out of the 10 bean jar. Put differently, if you had to purchase a chance to draw a bean from one or the other jar, the value of the 10 bean jar is 10% times $10 or $1, and the value of the 100 bean jar is 5% times $10 or 50 cents. If money or even red beans is what you're after, you'd be unwise to choose the 100 bean jar or to pay as much money for it as the 10 bean jar. But we see these relationships only if we think about it. Remember, this series of videos is entitled, Don't Make Me Think. Something in us prefers not to think. One participant in the study put it this way: I picked the 100 bean jar because it looked like there were more ways to get a winner. even though I knew there were also more black beans and that the percentages were against me. As Dennis Raj and Seymour Epstein, the authors of this study, put it, the participants readily acknowledged the irrationality of their behavior. Although they knew the probabilities were against them, they felt they had a better chance when there were more red beans. Our minds have several modes of operation. There's a continuum of consciousness that runs from comatose to high alert awareness, and there are two other modes that psychologists call by different names. Sometimes they call them System 1 and System 2 to indicate that each one is complex, but mostly they refer to one as intuition, emotion, or reflex, and the other as analysis, thought, reflection, deliberation, and the like. The analytical mode uses up a lot of energy and takes time. It's generally more accurate than the intuitive mode, but it is much more costly. The intuitive mode gives us quick answers, but the results are not always optimal. With the jelly bean experiment, the intuitive mind pushes us to go with a large number of jelly beans because our experience has told us that large means more chance. Don't think about it. Our mind was developed as a kind of automatic cost-benefit calculator. The cost of thinking is greater than the benefit, so our intuition does most of the work for us. Gert Gigerenzer calls this our fast and frugal way of dealing with life. Now, if your net worth was around $250,000 and we changed the stakes to $1 million per red jelly bean, and you either received $1 million or paid $1 million, and it was all your money at stake, your mind would likely switch to the analytical mode very quickly. You would instantly realize that this is worth thinking about, and you would. Think about it. And with a problem as simple as this one, you would almost certainly get it right. But lawsuits are not as simple as the jelly bean puzzle or the Wason card selection task. They are highly complex, and we have many opportunities to get it wrong. Yet, despite the complexity and the stakes, our bias is toward the intuitive mode. We simply cannot afford to be thinking all the time. We would never even get out of bed if we did. This is the end of part 1 of Don't Make Me Think, Why Smart People Make Dumb Choices. In part 2, we'll look at subconscious biases and the neurological basis of impulses and semi-compulsive behavior. We'll meet some biases that lead us to confirm and hold onto entrenched beliefs regardless of their accuracy, and we'll discuss our tendency to have a high level of confidence in predictions that turn out to be inaccurate. And in part 3, we'll discuss group decision-making problems and how best to deal with them. Thanks for watching.